Hi, today we're going to focus on standard MS-ES 3-1, which talks about the uneven distributions of Earth's energy resources and how they're related to geoscience processes. I highlighted the word energy because we're focusing mostly on energy today, mainly fossil fuels. So if you look at LT3, we're looking at what fossil fuels are, where they're located, and how they were formed. Let's get started. First, let's talk about what energy is. Energy is what we use to make forces and to do work. These forces can push, pull, and cause reactions in our world. These pictures just show different ways that energy can be used in our daily lives. So we can heat rooms, we can move around, we can move objects, we can power cars, etc. Why do we need energy? Energy powers our lives. All change in the world came from a transfer of energy from one object to another. So, for example, when we eat food, we transform the chemical energy in food into ATP, which is a form of energy that our cells can use to make heat or to move our bodies or to think, everything that our body needs to do to stay alive, right? We also learned about how energy gets transferred from one living thing to another via food webs and ecosystems. This is from first semester, right? When living things eat other things for energy, they transfer their energy from one part of the food chain to another. These are just pictures of other forms of energy. We need energy to charge our phones. We need energy to make weather patterns. We need energy to heat things in our house. So we need energy for many different things. There's different forms of energy. Mrs. Chen is a great way to remember the different forms. M stands for mechanical energy or energy for movement. So here's some examples of that. R stands for radiant energy or energy coming from sunlight or solar energy or any kind of energy that has to do with light. So another way to say this is electromagnetic energy. And this is that form of energy. Sound, S stands for sound energy. Sound energy is also a form of electromagnetic energy. So this whole branch right here deals with energy that comes from waves. C is chemical energy. Chemical energy is any type of energy that comes from chemical reactions, such as breaking down food or burning a piece of wood to form heat. H is heat energy. Heat energy is energy from heating things up. E is electrical energy, energy from electricity, and N is nuclear energy. Nuclear energy is energy from atomic reactions. So when you split atoms apart, it releases a huge amount of energy. And actually, that's the type of energy that's found in the Earth's core, and the type of energy that makes the sun bright and explosive as it is. Now, let's talk about if we can ever create or destroy energy. The simple answer is no, we cannot create or destroy energy. And that's called the law of conservation of energy. Okay, it's a law that states that we can't create or destroy energy, but we can transform energy from one thing into another. So, or we can transfer energy from one object to another object. So, for example, a plant can transform light energy into chemical energy via photosynthesis. It's not creating the energy, it's just transforming it into a new form. We can convert electrical energy into thermal energy when we plug our stoves into the electrical socket, right? So we're transforming electricity into heat. Here we're transforming food, chemical energy, into mechanical energy. So we ate food so we can power the bike. And here we're transforming chemical energy, fossil fuels, into mechanical energy. So we burn fossil fuels in order to power our cars. Okay? Now let's talk about fossil fuels in more detail. Let's take a look at these graphs. The top graph shows you how much of the United States' energy comes from fossil fuels, and you can see that almost about 80% of our energy comes from these three fossil fuels called coal, petroleum, and natural gas. If you compare it to the rest of the world, we see that the rest of the world is very similar. 78.4% of the world's energy comes from fossil fuels, petroleum, coal, and natural gas. Let's talk about what these fossil fuels are in more detail. Let's talk about petroleum first. Petroleum is a liquid. okay? Liquid fossil fuel, and it's found underground, and petroleum is refined into different types of fossil fuels that we use for various things. So, and they're formed in these places called oil refineries. This is what it looks like. And basically what happens at oil refineries is they take petroleum and they heat it up. And when they heat it up, the petroleum will actually boil. And petroleum is a mixture of all these different types of fossil fuels, like gasoline, jet fuel, kerosene, diesel fuel, and it also has chemicals that forms rubber, detergents, fertilizer, paints, and plastics. They're all mixed together into this form called petroleum. And basically what these plants do is they separate petroleum into these different products so we can better use them. Um, this diagram kind of shows you how they separate out these different types of fuel. So basically what they do is they heat up the crude oil or the petroleum, and as they heat it at different temperatures, different forms of the fossil fuel, so the different, the gasoline or diesel fuel, they will boil at different temperatures. And when a substance boils, it turns into a gas, and basically they will collect that gas at that temperature, cool it down, and it becomes a liquid, and that liquid can be used for other products. So this diagram basically just shows you the different temperatures at which different fossil fuels burn or boil, and these pipes kind of represent how they collect that gas once it boils, and they cool it down to form different products. So all of these different products were formed from different forms of petroleum that were boiled off at different temperatures. Now let's talk about the second type of fossil fuel, which is natural gas. Natural gas is a gas. Don't confuse it with gasoline. A lot of people think that natural gas is the same as gasoline, but it's not. You know that gasoline is found at gas stations, and it's a liquid that powers cars. Natural gas, because it's a gas, we can't really see it. Natural gas is used primarily for heating and generating electricity, and natural gas is processed at plants very similar to oil refineries, but they only get natural gas. We can separate natural gas into three different forms: methane, propane, and butane. Methane is used to heat homes, cooking, washing, drying. This is actually uses methane. Propane is used in heating fuel and cooking fuel for outdoor grills. Here's some other uses of propane right here. Um, and then butane is found in camp stoves and lighters. This is you probably have seen this. This liquid in here is actually liquefied butane. This diagram just quickly shows you what happens at the oil refineries. How do we get natural gas? So first we dig out the oil and gas from under the ground, then it gets separated into a gas processing plant, and then the gas company gets the gas from this plant and then distributes it to us, which are the consumers. Finally, let's talk about the last form of fossil fuel, which is coal. Coal is a solid. It's a solid form of a rock. This is what it looks like, and it's actually the most abundant or the greatest amount of fossil fuel in the whole world. You can burn coal to form heat and generate electricity, and it's really commonly used in many developing countries such as China to kind of power factories like this and to power transportation like trains. The United States, we don't really use coal-powered trains anymore, but in some countries we still use coal to power trains and vehicles. Okay, now let's talk about how these fossil fuels form. First, let's talk about petroleum and natural gas together because they come from the same thing. Petroleum and natural gas both come from these microscopic organisms, which are tiny little living creatures that lived in the ocean around 300 to 400 million years ago. And what happened is they died a long, long time ago, and they became fossilized by becoming part of the ocean sediment. And over time, lots and lots of sediment built on top of these dead microorganisms, and with lots of time, chemical reactions, and pressure, these dead microorganisms became petroleum and natural gas, um, which we can now kind of dig out with these wells here, right? Um, this diagram kind of shows you what we call the reservoir rock, and the source rock. So the source rock is where the fossils, the petroleum and natural gas formed, and the reservoir rock is kind of like a sponge that kind of absorbs that oil and gas out from the source rock and kind of keeps it there for us to drill down and obtain. And so reservoir rocks have tiny little holes like sponges that kind of keep the oil and gas there. And we squeeze it out by drilling holes down into this reservoir rock and kind of extracting it. Now let's talk about coal. Coal is formed not from microscopic organisms but from plants. Way back 300 million years ago, the earth was covered with tons of plants and swamps, and when they died, they got covered with dirt and sediment. And with increasing temperature and pressure, it actually made coal. Okay, so this diagram kind of shows you the process of how coal was made, and um, this explanation right here kind of talks about the whole process of how coal was developed. So bacteria and fungi will transform the plants into peat first. Peat has 60% carbon, and then as you increase the sediment and pressure on top of the peat, it turns into lignite, which is another form of the plants. That's 70% carbon. You keep increasing the temperature and pressure, the lignite will turn into bituminous coal, which is about 80% carbon, and then that turns into anthracite, which is the final form of carbon, which is about final form of coal, which is about 90% carbon. The bigger the amount of carbon in the coal, the more energy it contains. So this final form of carbon, which is coal, which is 90% carbon, contains a lot of energy that you can burn. Now let's talk about where fossil fuels are found. Here's a map of the United States, and you can see where we are in the Los Angeles area. We actually find lots of fossil fuels and oil, um, as well as this area right here and this area over here. We find coal, but you can see generally we find fossil fuels, all over the United States. If you take a look at the world map, you can see that oil is concentrated primarily in the Middle East, Russia, Canada, and some places in Latin America. But the main idea is that you can find fossil fuels all over the world, right? And that's also one of the reasons why it's so commonly used. Remember, 80% of the world uses fossil fuels for most of its energy. So, it just shows how common it is, how easy it is to get this form of energy to power our daily lives. Now, finally, let's talk about how we get these fossil fuels out of the ground. Let's talk about petroleum and natural gas first. You know that petroleum and natural gas are found deep under the ground, under sediment in the reservoir rocks. And basically, we have these wells where we dig right deep and down to the sediment until we get to where the oil and gas are. And then we have these pumps that kind of pump out the oil and gas where it gets processed at the plant. This is a picture of offshore drilling. Offshore drilling is when engineers mount drills onto ocean floors and we extract the fuel from under the ocean floor, because sometimes we find fossil fuels in the middle of the ocean. Finally, let's talk about how humans get coal. One way that we can get coal is by mining underground. So people will dig deep into the ground where coal is found to get the coal out. The second type of mining is strip mining, and this is when we will blast away or get rid of everything above where the coal is and expose the coal to above ground. So we kind of dug all this, exposed this, and then we grab the coal from here. And this kind of mining, people don't have to go underground, so it's a little bit safer. But at the same time, you're destroying all the rock that's above there. Next time we meet, we're going to talk about the consequences of using fossil fuels. But today we just focused on where we find fossil fuels and how they are